So we are going to be creating our first OpenAI plugin. And hopefully most of you already are familiar with that. That's why you're joining the call. If you're not, this is the plugin kind of ecosystem that's powering ChatGPT and soon even Microsoft products like Microsoft Teams Business Chat and Bing Chat. Now, I know a lot of you don't have access to ChatGPT testing OpenAI plugins, so we'll also be showing you how to test whatever plugins you build with Semantic Kernel, which is a TI program. Now, before we actually dive into building our first plugin, I just want to kind of set the stage for where many of us find ourselves in today. And that's, bosses or managers, everyone's asking us, hey, can you add AI can you make your app AI powered? Or you're thinking in a couple weeks time, I want to be joining a hackathon and I want to build something really cool with AI. But the problem, the challenge is it hasn't been super clear how to build AI integrations with your product, right? Many of you are probably .NET developers or TypeScript or Java developers, and you're looking enviously at what's happening in the Python world where they have all these great tools to do AI capabilities, technologies. And the goal from my team, the Semantic Kernel team, is to support all of you as app devs that use things like .NET, Java, TypeScript, so that you can take advantage of these AI capabilities as well. And we do that in two primary ways. One, and the reason why I'm doing a session like this, is we want to make sure you're armed with the knowledge and the metaphors and the mental models so that you can intelligently bring these capabilities to your apps. And then secondly, we're on this thing called Semantic Kernel, which I'll tell you a bit more bits, but that's supposed to help you as an app dev bring and merge these AI capabilities with your. And to the first point, understanding how to build these AI applications. In our team, the Semantic Kernel team, we really fundamentally believe it starts with understanding three key things. And you're going to hear me repeat these words over and over and over again. And I hope there's one thing you get from this session. It's what what plugins, planners, and personas are. Right? You're going to hear me say that over and over again. Plugins, planners, and personas. And obviously, because this session is all about building OpenAI plugins, most of our time will be spent looking at how plugins work, how to build them, how to use them. And then, as I mentioned, the other thing that we do is we ship this thing called Semantic Kernel. If you don't know what that is totally okay. It's still fairly new. It's essentially an open source project. If you go to GitHub and you search for Semantic Kernel, it'll pop up. And the main thing it tries to do, or does do, is merge AI capabilities, we call them semantic functions, with native code. We call those native functions. And you can basically build these pipelines, or in the AI space, they call them chains, that run these things together, and they can talk to each other using the same context. And you can combine LLMs with native code. You can get the best of both worlds so that you can accomplish user needs. What's great about Semantic Kernel is it's been built for .NET. We have a Python flavor and we have a Java flavor coming soon. If anyone is interested in helping us with our TypeScript version, volunteers are definitely desired. And it's very extensible. So right now what's super hot is all the OpenAI models. So Chat GPT 3.5 Turbo and GPT-4, whatever else comes next. But because it's extensible, you can also use models like Llama from Facebook or whatever open source models that come up from plugin events. And what we're going to be focusing on today are plugins, which is how you can enrich your Semantic Kernel application with triggers and. And if after the session you're like, wow, this Semantic Kernel thing's super cool, I want to learn more. If you download our repo, you can see it on the screen right now. We have the .NET folder open, and there's a notebooks folder. I highly, highly, highly recommend folks play around with these notebooks. You've never used a Jupyter notebook before? It's as easy as clicking a play button. It'll run the code. You can see what happens. In this case, this one that teaches you about semantic functions. We can see a particular prompt that we send to an LLM. And with the click of a play button, we can see how to run and invoke that function with Semantic Kernel and get a response. So it's a really great way. But enough about me trying to sell Semantic Kernel. Let's build a plugin. So what are plugins? Plugins, we believe, are the core building blocks for any AI application that you're going to build, whether it's a Copilot or some native integrated thing. Right now, most of kind of the world thinks of them as just like, oh, these are extensions that you can plug into OpenAI. But I want to challenge y'all to think bigger than that. And by the end of this session, I hope you kind of appreciate how you can create plugins to really give AI capabilities to any part of it. I mentioned you're probably most familiar with plugins from ChatGPT. Earlier this year, they said, hey, you have this thing called plugins. You can give superpowers to ChatGPT by giving access to the APIs of your service. And what's cool, what's great, is Microsoft at Build said, hey, we're going to lean in. And we also are going to adopt this standard so that when we support plugins in Microsoft Teams, Business Chat, or Bing Chat, you'll be able to use the same plugins that you've already developed for ChatGPT. If you haven't already seen it, I'm pulling up ChatGPT right now. You do have to pay for this, which I'll talk about in a bit. But here I have a conversation. Well, I've actually just created a new one.
There's a couple of questions here. Will I share those with you right now?
Feel free to interrupt.
So there was a question from Vikram about how is this similar / different from LangChain?
Okay, Semantic Kernel, yes. So they're very similar. So if you're familiar with LangChain, Semantic Kernel is basically Microsoft's open source flavor. We've been focusing though on a different persona, different developer than LangChain. We focus on enterprise developers, and so what that means, and you'll see in a bit later, we have a bit better like debugging and telemetry. We might not have some of the whiz-bang features that LangChain has, but if you are a .NET developer and what matters is building production apps that have minimal dependencies that you can monitor and actually know what the hell's going on, Semantic Kernel might be.
Just a few other ones very quickly then. Devanish was wondering, where do we find the notebook?
The notebook is in the Semantic Kernel GitHub repository. So if you go to Semantic Kernel and GitHub.
So I have that here. That's the Semantic Kernel repo. Post that. Okay. And then the last one was, are you going to discuss the relationship between OGLoop and Semantic Kernel?
I wasn't planning on it.
Leave it till the end.
At the end, I'll share some of the internal Microsoft, like what's going on with who's using what, how to integrate, what have you. How does that sound? Okay, so if we go to ChatGPT and we ask how much it costs to travel to New York from Dublin, which is where I'm located, Denver, the value of a plugin is obviously the LLM doesn't know this information, right? And if you really probed it and just make some stuff up. With a plugin, however, and this is using the Kayak plugin, it can call Kayak APIs in order to actually pull the correct information, and then the LLM can summarize it and give it back to the user. Really powerful stuff. To build on top of that, in terms of the services that y'all build, are basically this little globe. So I'm assuming from Microsoft, you're working on cool Microsoft products. You all have some sort of like either Microsoft Graph endpoint or some sort of endpoint that you could theoretically expose to an AI agent like ChatGPT or other applications, or even your own. Or you're working with a customer and they have their own services that they want to expose. So what's great about a plugin is you can wrap this information and give it to these LLMs so that they can start making these API calls. And these are a few examples if you're building like a CRM app. Now, as I mentioned, what's great is this is a really easy way for you to get started trying out AI things without jumping all the way in, right? We all have services. We all know how HTTP requests work. And so I'm hoping this AI concept is something that y'all can easily grasp and easily build so that you can start dipping your toes into AI without having learned everything like databases and memory and embeddings, a lot of like complicated AI terms. You don't need to know that for the first step, which is just Now, the last thing I'll say about plugins before I dive in, a lot of folks just think it's just a collection of API endpoints. You're just going to give the API endpoints, throw it to the LLM, and like it's going to be good. But it's more than that. It's those functions and semantic descriptions. What's different than what you've probably done before is you've described these APIs and documentation to humans. Now, you're having to describe what these functions are, what they do, and how to use them to LLMs, which basically means when you write these descriptions, when you write a plugin, when you semantically describe what is possible, you're basically using prompt engineering so that the AI can effectively call your APIs. So here we have an example from the Semantic Kernel repo. We have this writer plugin, which has a bunch of different functions. But the functions, they're great. You can call them. But what's most important is a description. That description goes into the player. We'll talk about what that is later, in order to satisfy that user's request. This example, it knows to use the short poem and story generator functions based on the descriptions the player was provided. So keep that in mind, so that as we build our plugin together, our ToDo plugin together, remember what's most important is not necessarily code inside of it. All of you can code. It's super easy. It's fine. And just creating another API endpoint. What's really different, what's new, is writing those descriptions so that the AI can call your APIs in the right way. So for the rest of this session, I have this link that you can go to. It has my GitHub repo that has all the sample code. You can try following along. As I was doing rehearsals, I realized I was cramming a lot in, so it might be difficult to listen to me and follow the GitHub repo at the same time. So one recommendation might be after this session is over, it is being recorded. You can, of course, come back to this GitHub repo and follow along and stop and pause and what have you. So with this ToDo plugin, what we're going to be doing is we're going to be creating an Azure function that is going to wrap a bunch of APIs from a ToDo service. And basically, ToDo service, you can create ToDos, you can mark the completes, you can get them back, all the basic kind of boilerplate behaviors that you expect. But we're going to wrap that in a plugin, OpenAI plugin, so that we can give it to something like ChatGPT, Semantic Kernel, or another Microsoft product. So if you go to this repo, let's just take a look at what this looks like. You'll notice that this is using kind of the one of the starters that the Semantic Kernel team has created. I haven't changed the reading too much. If you're interested on actually understanding how I even got to this point in this sample, we do have a great tutorial that's been written on how to create and run a ChatGPT plugin that walks through all the steps on how to take that starter and use it to build a ChatGPT plugin. So this is another great resource for you to check out if you want. It's in the Semantic Kernel docs. It's called Create and Run GPT plugin. Now, you might also be wondering, okay, what is this do service? What are we actually creating a plugin for? Azure has some really great samples on how to basically use every single one of the services, and they have ToDo samples. And so that's what we're using today. Before this session, I went ahead and deployed a version of this that I'll give access to everyone in a bit. But this is what the UI looks like once you deploy it to Azure. On the left here, we have different lists. And my ask for all of you is when we start getting, if y'all are following along, go ahead and create your own list. You can see I created one called Bolanos, which is my alias. So go ahead and type your alias here. And then when you navigate to your list, you'll be able to create items and all the good stuff that you want. And this is going to serve as that service. You can imagine this is your Microsoft product sitting behind Microsoft Graph, and we're going to build a plugin. Because what we want is I don't want to have to type in a bunch of new tasks and mark and complete myself. I don't want to click buttons. I want to talk to an agent and have it perform those tasks. And then on the right here, we have ChatGPT, but since a lot of you don't have access to that, I'll be showing you how to test with Semantic Kernel. And if we drill into the to-do function, the to-do plugin, what does it actually look like? These are the core building blocks of whatever you need to build an OpenAI plugin, right? There's three big pieces that I want to call out. One, I mentioned how important it is to semantically describe plugins. So the first place that you start describing things is the AI-plugin.json file. This is a JSON file that was defined by OpenAI. So actually, if we go to plugins and go to their docs, we can actually see what the schema looks like and what they're expecting. So this is what the JSON looks like. So you have basic things like, what is the name of this plugin for a human? What is the name for a model or the LLM? And same thing for description. You have one for human or model. You can start to see with just this example how you might describe things subtly different for a human versus an LLM. We'll talk more about what those differences are in a bit. The next thing, an open API spec. I hope this is very familiar to a lot of you. This is hopefully something that y'all been doing for years now. Oh, I build a service, I create some endpoints, and in order for someone else to actually use it, I better document it as an open API spec. And because this is so familiar to a lot of you, it's one of the main reasons why I hope that this is a really great intro into AI. We're not doing anything radically different than what we've already been doing for a year. And then lastly, we have the HTTP endpoints. This particular demo will be showing how to get tasks, create tasks, and then mark them. Alrighty, let's look at some code. So I have already pulled down the to-do AI plugin. This is what you should see. There's two projects in here. One is the actual Azure function with all the different endpoints. That's what we want to be focusing most of our time on. And then we have this thing called Semantic Functions Generator. Just pretend that doesn't exist yet. We'll talk about that later. Okay? So let's focus on the Azure function. If we take a look at our diagram, let's find those three key parts that I discussed earlier. So first is the AI-plugin.json file. So we had a class here that describes that Azure function. We can see that's being served at this .wellknown/AI plugin.json. OpenAI is very, very strict. They only look for this file in this root folder of your domain. So just keep that in mind. And then inside of the starter, we make it a bit easier for you to define all those settings within your app settings content, where you can see all those different values. Description for model, description for human, et cetera, and we plug that in and serve that back out as JSON. So that is the AI-plugin.json file. The next thing, of course, is the open APIs. I'm just realizing, like, there's a huge lag on whatever. Is it distracting how laggy it is? So we have our open API spec. And the way we define that is if we go to one of the functions that we've defined, here I have open the get to do's function. And we can also see in the navigation, there's also the create one and the mark of complete. I'm starting to define them with these open API decorators. We're using this tool so that we can automatically create our open API spec. What I want you to kind of start focusing on is the descriptions that I'm providing these things, because it's what's going to be used by the LLM. Now, once you're ready to actually run this thing, there are a few things that you need to configure. These are defined in the README if you want to follow along later. One is you'll have to have your own local settings.json, where you're going to put the API key for your LLM service. And then in the app settings, you'll also need to provide the ID of your list, which is the ID that you find in the URL. So here the ID is BEA, something, something, something. So you'll copy that in. And then you'll want to update the endpoint information for your Azure OpenAI service. Just to connect the dots a bit, if you have your resource open, you'll want to copy in the endpoints and for model deployments under managed deployments. Hopefully you've already started deploying some models. If not, you can easily create a new one. Here we can see all the different models that I've deployed to Azure AI Studio. And for most of the scenarios that we're showing today, what I would recommend is to use GPT 3.5 Turbo. You can see the deployment name of that is GPT 35 Turbo. We don't have the period. And that is what you're seeing here with the deployment or model ID. Once you've configured the app settings, and once you've created your local settings.json file with your API key, it's now time to actually run this thing and see what our plugin actually looks like. So we're going to go ahead and click the run button to start the Azure function. I'll wait for it to build. And so that we can see all the different endpoints that we have created. Now, while this is loading, you might be wondering, Matthew, I already have an API set. I already have these things sitting around. Why can't I just give this to the LLM? The reason, there's a few of them, is an LLM, as much as we think they're super smart, they have limits. And if you were to give an LLM all of these functions, it would become quickly overwhelmed and it wouldn't know what to do. So that's number one. Two, I kind of mentioned this a bit already. The way you semantically describe something for a human and for a model is subtly different. You might provide some extra hints in the model descriptions that you wouldn't give a human. And so you don't want to necessarily pollute your existing docs, your existing OpenAPI specs with a bunch of like model-specific text. It's not good. And then the last thing, I would expect that the return types might be different. Again, if you send a huge JSON of like every single property of your API, that might work for a human because they know which ones to pick out. But an LLM has to read all of that. And reading through very large outputs can get really confusing. And so that's why I'm recommending that you create, and it looks like it's spun up. That's why I'm recommending creating an API that's smaller and more maintainable for your plugin. In this case, we just have these three functions that are simpler for the LLM to use. I think I've seen a few questions. Are there any that I should answer?
There's questions here. So I was going to read them out in the sequence that came in. The first one was, how does the LLM choose the right plugin to use for generating an answer? Let's say we have many plugins.
We will get to that. So once we're done, we're actually about to test it, and I'll show y'all how that works with planners. But I'm about to show you how to test this plugin without using ChatGPT. That does have some starter scripts. We don't have a container. It's not like a Docker container or anything. But we do have some starter scripts to make it easier to get started. Which is a great segue. Okay, so we have our API. We have these different things. Now we want the LLM to actually use it. And how do we test it? The challenge we find ourselves in today is, one, there's a wait list. And even people within Microsoft even when we like annoy the OpenAI people to get access, they still don't get access. And it costs money, and no one likes spending money. So what we have done on the Semantic Kernel team is basically create a ChatGPT style clone where you can import and test your plugins with similar logic that ChatGPT has. so that you can start seeing how your plugin would behave in something like ChatGPT, or in the future, Teams Business Chat, or Bing Chat. And that is Chat Copilot, which is Semantic Kernel's reference app to test all of your OpenAI plugins. So someone asked, like, hey, is there an easy way to like spin these things up and test it? I would highly, highly, highly recommend to use Chat Copilot as like your reference application to see how you would build an advanced AI product, with Semantic Kernel in particular. So if you just search for Chat Copilot Semantic Kernel, pop up. This is its repo. It's Chat Copilot. You can see a sample of it kind of working. We have some great starter scripts. This is where if you're kind of trying to follow along, this is probably where it would take too long, and you might have to try this offline after the session. But basically, you give it the information of like which AI service and what's your keys, and then it'll set up all the configuration, and then you can start it so that you can actually use this thing. That is exactly what I'm going to do. So here I am inside of the Chat Copilot repo, and I'm already inside of the scripts folder, so I'm going to go ahead and start it up. This is going to start both the back end. We have this web API folder, and the front end, we have this web app folder. It's all React. And in a bit, we will see our chat application where we can start testing our plugin. So standard chat interface, if I want to, I can create some new ones. What's most important for us is we want to start loading in our plugin. Okay. So we have this nice little card at the top for custom plugins. We're going to go ahead and select add. We will search or select where our current Azure function is being served up, which is localhost 7071. We're going to search for the manifest. It performs the exact same validation that OpenAI performs, so that you can make sure that your OpenAI, your AI plugin JSON file and your Open API spec is working correctly. And then once we've added our plugin, I'll look at that. We can enable it. And now this is the moment of truth where I pray to the demo gods that everything works out well. So we can now ask the AI questions that require the use of our plugin. So I can say something like, can you tell me all the tasks I have? And one of the questions was, how does the LLM know which plugin to use? Behind the scenes, it's using what's called a planner. We'll dive into that in a bit so you can actually see how it works. But a planner is basically just a really big prompt. Like I thought, a really big, that asks the LLM, hey, you have all of these functions. These are all the things that you can do. This is the user's goal. Tell me how you can use those functions to achieve this goal. And what we're seeing here in our Chat Copilot application is it doing just that. It knew it had this function called get to-dos, and it's returned back a plan. This is a really simple plan. It's just only one step that gets the list of tasks and returns it back to the user. And what's nice is I can see the plan before it actually runs, so I can confirm or deny. So I want to say, yes, this looks great. Semantic Kernel can then take that plan that was generated by the LLM, run it, and give it back to me. What we're seeing right here is spitting out. This isn't great. We have to fix that in a bit. I'll show you how. But what it's doing right now, if we click on this little info button, this is what I really like about our Chat Copilot experience. It actually shows you kind of the inner workings of Chat Copilot, which is something that you don't get from ChatGPT, right? It's kind of a black box. Here, we can see what was set as a details to the LLM, and everything inside of this source start, this result, is the data that came back from our plugin. We can see like it basically pasted out all this content. We could actually, if we went back to our Open API spec and ran the get to-dos, execute, You actually see it's like this exact same content, right? Putting out. So that's what's given to the LLM. And the LLM is then just like, well, this is what you wanted. This is what I got for the API. I want to vomit it back out to you. Now, this is not ideal though, right? If we built a plugin and we tested it and we realized that it's just spitting out like non-helpful things, you need to find some sort of way to coax the LLM to be more friendly to you. So one way of doing that is we can add an additional function to our set of APIs that will summarize, that will make it more human readable. And to do that, we're actually going to use an LLM in our plugin, right? This is a big moment. I want to say it again. We can use LLMs, we can use AI inside of our plugins. A lot of people just think plugins are just like, oh, we're going to call APIs to our existing services. You can also make them smart. So that's exactly what we're going to do. If we go back to our plugin, we can see I have a folder here called prompts. And I have one called summarize list of to-dos. And these folders are what we call in semantic kernel land semantic functions. They're composed of two files. One is a configuration file that, again, semantically describes what this function does. In this case, it summarizes a list of tasks. And it also comes with a prompt that we send to the LLM so that we can get the information back. This particular prompt has to summarize some information, asks the LLM, hey, can you tell me what's most important? And what's great about these semantic functions is with semantic kernel, you can templatize your prompts. So here we've templatized the list of tasks that are set to it so that every time you call this function, a different behavior. So I created these semantic functions. Now we actually need to expose them as part of our Azure function. I mentioned we were going to ignore this semantic function generator. You can take the blindfolds off. We can take a look at it now. Basically what it does is it looks for all of the semantic function files and then creates Azure function endpoints for us to call. And I'm just going to come back into my project folder and enable this generator so that when I run this semantic function again, we'll have those two additional endpoints. So just to recap kind of what we've been doing. So we created our basic plugin, which had some API calls. We tested it in Chat Copilot and realized that it wasn't a lot great, kind of scary to humans. This is scary. I don't like this. And so now we're going back to our plugin and making it better by giving it some intelligence so that it's smart enough to make this a little bit more readable. So it looks like our function is up. You refresh our page, we should see these two new functions. Great, they're there. And now, if we refresh our Chat Copilot, it'll be back in a clean slate. It add our plugin backend. And now knows about these new functions. Nice. And now we're going to ask the Copilot, please summarize the tasks. Okay. And again, it's sending this request over. It's sending it to the planner. Again, I'll show you what the planner is in a bit. But here, it was smart. We have now not just a one-step plan, a two-step plan. One to get the to-dos, and the second one, we're now calling this new function we created, summarize list of to-dos. And really like about Planner is it's smart enough to take the outputs of the first step and pass it as an input to the next step. Pretty cool stuff. You can start seeing how it can automatically create these chains of these functions, right? I'm going to go ahead and say, yes, proceed. Cool beans. And it's going to run. And if we're lucky,
Next couple of questions. With what you've explained so far, when Planner comes into play and supports the orchestration of plugin?
that's a great segue. So I'm just going to head into that and talk a bit about what Planner is. So Planner, I mentioned earlier, is you give a goal, and there's this big prompt that then takes that goal and creates a plan. And in Semantic Kernel land, we actually have 3. And it basically kind of shows the evolution of how the entire AI community was thinking about these planners. Generation 1, we call it action planner, and it chooses a single function to call for a goal. One action. Pretty dumb. I don't expect anything else to use it. Generation 2 is what you've already seen in the Chat Copilot. It's called sequential planner. And it generates a complete plan to accomplish a goal. And what's nice about things being open source is you can actually see how things work. And like, ChatGPT, like, how does it know? What's nice about Semantic Kernel is we can take a look at the code and find out how it knows. If we go into our .NET and go into some extensions, we can see the different plugins or planners I was describing: action planner, sequential planner. Talk about stepwise in a bit. If we go into sequential planner, you actually look at the prompt that is used by the LLM to create a plan. So here, it provides some instructions like, oh, this is the schema you use, and there's an input and output, and like you need to pass things. This is kind of what it looks like. And probably what's most important is at the top here, we actually paste in all the available functions. The bottom, we brought bold. And this is all sent to an LLM. And this is enough for it to bring back some XML that the rest of this code, what it does, and it just parses that XML so that the semantic kernel can actually write over whatever the LLM has. This is whenever you're bored and you're like, oh, let's see how planners work. It's fun to just like look at these prompts and go, oh, that's kind of cool. That's kind of cool. The last one, we call it stepwise planner. We believe this is what ChatGPT uses and more or less what Bing uses. Instead of asking the LLM to create an entire plan all at once, which can be very hard and sometimes it doesn't get the right answers, we ask it to iterate. We almost basically trick the LLM into like thinking. LLMs don't think, but close enough, right? And if we look at the prompt there, we basically give it the instructions, the steps to have a thought. Start with a question, have a thought. How would I actually address this? Perform an action, do something into the real world, get some results back, observe it, and then loop. Repeat that over and over again. Have a thought, do something, observe, and just do that over and over. It's kind of what people do, right? Like we interact with the world, see what happens, and we try again until it has a final answer, and now you can return back to the user. And so what I'd like to actually show you is we can of course test this in Copilot chat. We probably don't have time for it, but you can also of course run things in code. We haven't seen enough code yet, so I want to pull that up. So what I have here is a simple program file where I am creating a semantic kernel, and I am pulling in the plugin manifest for our to-do plugin. And I'm calling it math plugin. It should say to-do plugin here. And we're going to ask it a simple question. I finished feeding the dog. Can you mark it as complete? Let's actually see it, make sure we have a task. Okay, so we have this task called feed the dog. And we want to mark it complete because I finished it. And what this code is basically doing is it's creating a new player using the stepwise player. So it's going to do that thinking loop. And then we're going to get a result back. And I mentioned, someone asked a question earlier, what's the difference between semantic kernel and LangChain? This is probably one of the biggest differences. we really, really wanted to make sure that people could see what the heck was going on. And so we've added a ton of debug logs. We're adding some hooks so that you can start adding telemetry. We have app insights that support, so that if all this stuff is really complicated and the AI can randomly call random stuff, and if something breaks, you need to know why. You need to track down what happened. And so by using something like Semantic Kernel, we're just doing a bit better job of actually logging all this stuff down. And what we're seeing in the debug console right now is actually the LLM performing this chain of thoughts. So it's starting with a question. Okay, start with a question. Hey, I finished feeding the dog. Can you mark it as complete? It has a thought on how to actually achieve it. So it's first saying, like, I don't know what the task is. Like, I need to find the task to actually mark it as complete. So first performs its get to-dos. Like, gets back the list of all the to-dos that are returned by the API. And now says, okay, I have a list of tasks, but I need to find the one that is actually about feeding the dog, because it's not necessarily clear. And so there's another function that I added called get relevant to do, where it passes in all of the information and the description of what the search is. And it comes back with element 2, with the ID of the relevant to do. And now, if we scroll to the bottom, once it's gotten that ID, it now has the thought, okay, I found the task, I'm successful, it has the ID of 74 whatever, I'm now going to mark this as complete. So now it's smart enough to call the mark to do complete function, and it observes that it's successful, and it's done. And here in the terminal, we can see it completed it with 4 steps, and it used 3 different skills. And if I refresh this page, it should, be marked as done. And so that's kind of the power of stepwise function. I can do a little more complicated things than the sequential planner. If I just ask sequential planner to do that, it'll probably just like vomit and give up. But with stepwise, it can actually. I'm going to transition and see if there's any other questions. And I want to wrap up give you all some last remaining thoughts as I wrap up this session. Are there any more questions?
Yeah, there are. Okay, so are there any specific limits for context size for semantic kernel?
It depends on the model. So each model, like 3.5 Turbo, has, I don't know what the context sizes are. But basically, the more advanced the model, typically the larger the context sizes. That's also why if you had a keen eye, you probably noticed somewhere in the debugging here. I'm going to give up. It said I was using GPT-4. You're using a planar because you do need more tokens. You typically need to use
Okay. Does OpenAI support ChatGPT-4 now? 2 months back, it only supported GPT 3.5 Turbo. And that may already be announced in the chat.
Yeah. Basically, you need access to GPT-4. You have to be on a wait list, whether that's OpenAI's wait list or Microsoft's wait list. Access to GPU is very tight right now. So you might just have to wait a bit until servers are instructed where they need to be instructed.
And again, this may have been answered in the chat, but I'll ask you anyway. Should the plugin be always an Azure function, or can it be some sort of web service?
Oh yeah, make it whatever you want. What I'm hoping you got from this isn't rocket science. I can create some API endpoints, create them however you want. Whatever makes most sense from like a COGS perspective, or like whatever it is, right? All that matters is if you have these things described in the way that the L.
And do we have a Python flavor coming for the plugins to be developed?
Yes, it's actually already available. We have a starter for that. It's not documented yet, so you can hate me for that. Hopefully by the time the hackathon rolls around in a couple of weeks, that'll be documented.
Yay! Can Stepwise Planner get into an infinite thinking loop? Is there a breakpoint if it's stuck?
In the configuration, you can say max steps, but yes, it can get stuck in a loop. That can happen. So normally depending on your scenario, you'd say, the max iterations is like 5 or something.
Does it matter which version of does it matter which version of GPT 3.5 Turbo, that is version 0613 or 0301? In a recent hands-on, this mattered, and 0301 is only available in East US, not East US 2.
So I know. So there's also a GPT 3.5 Turbo version 1 that does not work at all. So don't use that. I've only tested with the May version, the 0301. I have not tested with is that June? The 6th version. My assumption is it works. I haven't heard otherwise.
And then, can I do this with any application as long as there is an API for it and I can create these planners, etc.?
Yes, that's the goal. You can give these AIs power to do anything, which is scary. And remember to practice responsible AI. But that's kind of the dream, is anything that has an API endpoint, these AIs can automate.
I give one last question here. How would it work when you have users authenticated in an app?
Great question.
Does it have access to the user ID or email and then is able to use it as a parameter to an API call?
So great question. The Chat Copilot experience does have a login experience, and there's some samples of how to like pass authentication around. The OpenAI standard does have some way of defining authentication. I get told by the Azure AD team that it wasn't well thought through, and they have thought. But it is possible to do authentication and pass tokens through the plugins. And over time, it'll get better.
Okay, if there are any final questions, just come on to your mic and ask them off. Matthew, is there any wrap-up? Is there a wrap-up you want to do?
Real quick wrap-up. One thing to note, planners aren't perfect. You can read this. One of the recommendations I would have is, instead of having a bunch of atomic functions, wrapping them so that a planner doesn't have to do as much staking, and would just tease. Semantic Kernel is working on a thing called personas. We don't have time now, but get excited.